These uranium-rich rocks may appear ordinary, but locked within their mineral structure is an extraordinary amount of energy. What begins as a tiny piece of uranium ends with one of the most destructive events ever created by humanity.
The journey to nuclear energy begins with precision drilling.
Engineers use advanced software to access the uranium deposit hidden underground. Once every study is complete, construction of uranium mine begins. Before mining can begin, powerful ventilation systems, communication networks, emergency exits, and radiation monitoring equipment are installed. Every step follows strict safety procedures and is monitored from secure control stations.
Once the rock has been safely excavated, heavy mining equipment begins collecting the broken ore.
The extracted ore now begins its journey through an underground transportation network. At the processing plant, enormous crushers reduce the mined rock into smaller pieces. The crushed rock continues through a series of crushers, gradually becoming a fine mineral powder.
Water is added to the finely ground ore, creating a thick mineral slurry.
Inside enclosed systems, the uranium minerals are separated from the rocks through carefully controlled industrial chemical processes. The uranium-rich solution is now separated from the remaining rock particles using large industrial filtration and settling systems. Advanced recovery systems separate the dissolved uranium from the remaining liquid, concentrating it for the next phase. After recovery, the uranium-rich solution is carefully concentrated. The dissolved uranium begins transforming into a fine yellow solid. This is commonly known as yellow cake. The newly formed yellow cake is separated from the remaining liquid using powerful industrial filtration systems. To achieve the required purity, the yellow cake passes through carefully controlled washing stages before drying. The dried concentrate now enters a carefully controlled thermal stabilization process. After stabilization, the uranium concentrate is gradually cooled to prevent contamination and maintain product quality.
Every container is filled automatically under tightly controlled conditions, ensuring precise weight, complete traceability, and maximum safety.
Before leaving the facility, every drum undergoes rigorous inspection. Automated systems verify weight, seal, and quality before the product is approved for shipment. Before any shipment is approved, samples from every production batch undergo comprehensive laboratory testing. Every sealed container passes through multiple inspection systems before leaving the processing facility. Once certified, the drums are transferred to a secure storage facility where every container is tracked, monitored, and stored under carefully controlled conditions.
Every shipment follows strict regulatory requirements before beginning the next stage of the nuclear fuel cycle.
Once every inspection is complete, the sealed containers begin their journey under carefully regulated transportation procedures.
The uranium concentrate travels inside certified transport containers along carefully planned routes.
After completing its journey, the shipment arrives at a licensed industrial facility, where another highly controlled stage of the nuclear fuel cycle begins.
Inside the receiving facility, automated handling systems carefully unload every container.
The uranium concentrate is transferred into enclosed preparation systems, where automated equipment ensures consistent handling.
The uranium concentrate undergoes another highly controlled industrial transformation.
After passing every quality and safety check, it is approved for the next stage of the nuclear fuel cycle. The journey continues at a modern fuel fabrication facility, where certified materials undergo rigorous quality controls before entering the manufacturing process. Inside the facility, the material moves through enclosed preparation systems, where automated equipment carefully controls every transfer before manufacturing begins.
The material is carefully conditioned into a highly uniform ceramic powder.
Powerful automated presses shape the conditioned ceramic powder into thousands of identical cylindrical pellets, each manufactured to exceptionally tight engineering tolerances. The newly formed pellets enter long, high-temperature furnaces, where carefully controlled heating transforms them into ceramic fuel pellets. After thermal processing, every ceramic pellet is precision ground to achieve an almost perfectly uniform size and surface finish.
Every pellet undergoes multiple automated inspections. The finished pellets are prepared for the next stage of automated production systems to assemble them into precision-engineered fuel rods. Individual fuel rods are carefully assembled into larger fuel assemblies. The completed fuel assemblies are securely prepared for transport.
The completed fuel assemblies arrive at a modern nuclear power station. Every shipment follows carefully regulated procedures before entering the facility.
Inside the station, the fuel assemblies are carefully transferred through highly controlled handling systems.